Hello everyone, welcome to the live session. Okay, so as you guys know, uh, based on our thumbnail and all the places we have posted, that what we are going to do today. So today, basically, I have a data set with me, which is about students. Okay, in which um, that data set basically captures the information about the student food habits and lifestyle choices, which is used to explore their statistical relationship with the academic performance. Okay, that will be measured by the GPA. So I have downloaded that data set from Kaggle. You guys can also go and found the data set, okay, and work with that. So basically, that data set has uh, that is a CSV file, which is in row and column format. So each row demonstrating the each student, okay, and there are several categories, means the columns. There are approx 61 columns in that data set, okay. So we'll see one by one. We'll explore all the insights. We'll try to clean the data. We'll first check that whether that data is having some missing values or not. If there is missing values, we'll find some alternative ways, or we'll see that how we can fix the data missing values, how we can handle it. Okay, and after that we'll perform EDA, exploratory data analysis, on that. Okay, using several plots, we'll see and bring out some insightful data. Okay, and we'll understand how plots works. Okay, so these are the things which we are going to do today. Okay, but before starting with our programming session, before starting with our analysis, what we are going to do, what we always do, is to make our session interactive and more engaging. We always first start with the quiz session. So let's start the quiz session now. Typically in the last live session I have used, oh, we co-create first comment, guys. Yes. Yeah, great. You guys have joined. Okay. So now let's start with our first question. So as you guys know that our first session was based on data cleaning. The last live session was based on data cleaning. So I have bring up questions based on data cleaning only. Okay. So let's see how many of you have uh, seen our last live session and have learned from it, or you guys, how much you guys know about data cleaning. Okay. So these questions are very basic in nature. Now the first question is on your screen. As you can see, question number one: can missing values in a data set be identified using the is null function in pandas? Uh, Ronald Kanyepi saying, joining from Atlanta, USA. Uh, from USA. Thanks, brother. Thanks for joining. I hope you like this session. Okay, and I hope you learn something from this. Okay, so thank you for joining. Please stay, uh, stay till the last. Okay, so I'll try. This live session is going to be little short, okay, because we are directly going to switch, okay, to direct data analysis just after the live session. So, Suvam Jain, love you, sir. I am back. Yes, I remember you. Same, brother, same. Thank you so much, Suvam, for joining the live session. Uh, yeah, quite a few interactive audience. Okay, so guys, the first question is on your screen. That is question number one. Can missing values in a dataset be identified using the is null function in pandas? Yes or no? Nope, we use is na. Yeah, they both are the same. Okay, you can use is null or you can use is na. They both do the same thing. Okay, so yeah, both acts different. Both the behaviors are same for both the functions. So you can you can use both of them. Yeah, that was also very nice. Is na. Yeah. Okay. Okay. So I can see one yes in the chat for the question number one. Okay, that's good. Anyone else who knows the answer? Okay, so they can reply or otherwise we go with yes. So, okay, I can see one yes in the chat, so we'll go with yes. So yes is the right answer, okay. And the alternative can be we can use is na also, likely our brother said, okay, in the chat, okay. So that's the same. Okay, as I said, you can use is na too. So is null, is na both can be used. Okay. So if it is null also, then also the answer will remain yes only. And as you use is na, so for you also the answer is yes. But they both functions are same. They do the same thing. Okay. So the answer will be yes. Okay. Now let's move to the next question. That is question number two. Is it possible to remove duplicate rows from a data frame using the drop duplicates method? Yes or no? Okay, I repeat the question number two again. Is it possible to remove duplicate rows from a data frame using the drop duplicate method? Yes or no? Yeah. So as I can see, couple of yes in the chat. So I'll go with yes. So yes is the right answer for this question. Okay, as drop duplicates removes the duplicate rows from a data frame. Okay. Now let's move to the next question. That will be question number three. Does the fill in a function allows you to replace missing values with a specified value? Yes or no? Okay, one more yes for question number two. Yes. Yeah. Yeah, Ronald, you are correct. Now, guys, the next question is on your screen. That is, does the fill in a function allow you to replace missing values with a specified value? Yes or no? Okay, I can see one no in the chat. Okay. Okay, so I can see one no and a couple, two yes in the chat. Okay. So I'll give the answer. The answer is yes, okay. So for question number three, it is yes, because this is the right function. Fill NA is a genuine function which is used to replace, or you can say fill the missing values with a specified value, okay. So replace means we are filling it. Means initially there is nothing, the value is not there. Initially there is none or nan, okay. And then we are replacing it to some specified value. So actually it means we are filling, okay. So replace is also being used here for filling only. So fill NA is the correct function. Okay. So answer will be yes. Now, next question, that is question number ah, four, that is on your screen now. Yeah, the question is, should outliers always be removed during the data cleaning process? Yes or no? Now, I feel uh, we have in our last live session also, I feel I have keep this question. Okay. So the smart people will know, those who have joined the last live session, they can answer it, okay, correctly. Okay. uh some perfect not is saying four yes. Okay, so for question number four, it's saying he's saying yes, and he's saying that in last live session I said no. Okay, okay. So in the last live session he has said no, and now he's saying yes. So now, bro, you give the answer to all the people. Okay, so now I'll just directly take. Okay, I'll directly take yes. Okay, and yeah, rightly said. So those who have said no, it is correct. Okay, yeah, Ronald, you are correct. Okay, and everyone who have said no, it's correct. Why? Because it's not always that the outlier should be removed. Okay, sometime it matters. Okay, so you have to interpret the data set. Okay, and based on that you have to make the decision. So you directly cannot say that you have to always remove the outliers. Okay, so that is one thing, you don't need to remove the outliers always. So yeah. Now the next question, that is question number 5, is on your screen. That is, can incorrect data type, that is numbers stored as strings, be corrected using the as type method, as type method? Yes or no? So guys, question number 5 is the next question. Okay, so please read the question and answer accordingly. Okay, you have to answer by saying yes or no. Okay, I can see a couple of yes in the chat. Question number 5. Mm, okay, so now I guess there are two yes in the chat, so we'll go with yes. So rightly said, those who have said yes, it is correct. Okay, we can change the data type. Okay, using the as type method if numbers are stored as strings. So yeah, let's move to the next question. That is question number 6 on your screen. Let me make it in bold. So guys, your question is that is it necessary to handle missing values before performing most machine learning algorithms? So for most of the machine learning algorithms, is it necessary to handle the missing values? before, before. Is it necessary? Yeah, I can see one yes in the chat. Okay, that's nice. Okay, Ronald is saying yes, unless if it's decision tree. Okay, okay, yeah, that's correct. Uh, yeah, so I can see um most of the people are saying yes, okay, for the question number six, and that is correct also. Okay, that is totally correct that the answer will be yes only, because sometimes it impacts the decision, or the decision can be means it can be means it can give correct it can make wrong predictions. Okay, if you are making like that, so if you train or model on that, so it might affect, okay, your training. So it will be trained on what you say, on bad data. So then it will not be that much efficient. Okay, it will be effective, it will do the work, okay, but it will be not accurate. So that can be one of the issue. So yeah, necessary. So yes is the correct answer. Let's move to the next question, that is question number 7, that is on your screen. um, does the replace function in pandas help in correcting inconsistent or invalid values? Yes or no? Okay, I'll again repeat the question. Does the replace function in pandas help in correcting inconsistent or invalid values? Yes or no? Okay, I can see one yes in the chat. Okay, as I can see one yes in the chat. Okay, so let's go ahead with yes. So rightly said, yes is the correct answer for question number 7. The replace function in pandas um, can help in correcting the inconsistent or invalid values. So yes is the correct answer. Now let's move to the second last question, actually the third last question, that is question number 8 on your screen. That is data cleaning only required for large data sets, not for small ones? Okay. For question number 8, is data cleaning only required for large data set, not for small ones? Yes or no? Okay, I can see couple of no for question number 8. Okay. So for question number 7, it was yes. And as I can see, couple of no in the chat. Okay, so they are correct. It's not compulsory or it's not primarily said that only for large data set. For small ones also, you need to perform data cleaning. Okay, so for each data set, if you have to perform EDA or if you have to go ahead, okay, so data cleaning, we have already discussed why data cleaning is important because 70 to 80% the work which we do on our data set, okay, that is data cleaning only, okay, that is very important, and in which we cover 9 to 8 steps, okay, which are according to me which are mandatory we should do, okay, so that is the thing we need to do that thing. Data cleaning is very important because to make means see raw data, whatever the data set we have, that can be a raw data, okay, that we store from real world, okay, so they it can have missing values or the data types can be changed, so there could be many irregularities in the data set. To make that data set a good one, a perfect for, because if you will clean the data set nicely, okay, then only when you'll try to train the data for your future predictions or for whatever purpose, okay, for ML thing, so then what will happen then basically, you will get the uh, you will get the accurate results, the efficiency will be good, the accuracy score will be good, okay, the recall and everything will be top notch, okay, so that is the thing, that's why it's always you need to clean the data, okay, and for cleaning the data you need to understand the data set, okay, that is the important thing. Now let's move to the next question, that is question number 9, okay, without okay, question number 9, can column names be standardized, okay, in lowercase or by removing the spaces, okay, using Python string methods? So basically, can we change the column name to a standardized form? Yes or no? Now that's very easy. I guess every will reply easily. Okay, I can see yes for question number 9. So without wasting time, I go with yes. Okay. So yes is the right answer for question number 9. With that, we have came to the end of our live session with this question. Okay, with question number 10. So let's see this question also, and then we'll be ending the quiz session. Now, question number 10 is on your screen. That is, does data cleaning improve the accuracy and reliability of data analysis result? Yes or no? Okay, yeah, Ronald. Yes, two lower or two upper or strip. Yes, yes. These kinds of things which we can apply on our column. Yeah. So these are the things which we can apply on our column to to make the column names in standardized form so that it should be easy for actually it will be easy for us whenever we try to access any of the column names, any of the category, so it will be easy for us only. So that is a good habit that we should follow whenever we are performing data cleaning and all, okay, so yeah. Okay, as I can see for question number 10 also, everyone is saying yes, so yeah, they are correct. Yes is the correct answer. Okay, data cleaning, yes, it affects the overall accuracy, reliability. That the same thing I have told you in, I guess, any on one of the questions. Okay, that it overall affects the accuracy and everything. Okay, so that is the thing. that we should always perform data cleaning on our data set. Okay, so yeah, that is the thing. Okay, now guys, with this, what we are going to do, basically, I am using a data set, okay, which about which I have already told. I have given you a one or two line description about the data set which I'm going to use today. Okay, that data set is basically that data set contains it was a survey. Okay, it was a survey held by, I don't know the whole detail about that data set, but what I have found and read about that data set. So based on that, data set contains the survey based data, okay, on students food habits, lifestyle choices, and their academic performance. Okay, now it was designed to analyze how dietary patterns and daily behaviors are associated with the with students. Okay, and how they affect in the grade point average, that will be GPA. So this grade point average is going to be our target variable in our data set, and rest of the other uh, variables, it means the rest of the other variables means other columns, that will be our features. So based on that, we will see that how it affects. Okay, so we'll perform our now guys, one more thing, all the rows here, each row represents one student. Okay, so one row means it representing one student, and the columns, so there are total 61 columns, means 61 variables, um, which which in overall covers the academic, the food intakes on breakfast, on lunch, okay, their lifestyle, then exercise, whether they play sports or not, okay, uh, in non-veg what they have, how many protein intake, and all the other demographics detail. Okay, and the target variable, as I said, is the grade point average. It means the GPA. So GPA will be the target variable here in our data set. Okay. And in the GPA, the numeric measures of the academic achievement will be between 0 to 4. Okay. So 0 to on a 0 to 4 scale, 4 being the highest and 0 being the lowest. Okay. So now rest of the things we'll discuss. Okay. So first of all, what I will do, I'll let me just now load all the necessary libraries, and then what we'll do, then we'll discuss more about the data set, because that is the main important thing. Okay, whenever we have to perform data analysis, so the first thing is to understand your data set. So first of all, I'll start by importing. Okay, I've written import as numpy. Yeah, so import numpy as np to perform our numerical operations. Okay, I will use numpy. Then there is pandas as pd. Yeah, so for when I'll perform the EDA, so then I'll use some plots. So for that I'll use matplotlib.pyplot, and one more I am going to use, that will be seaborn. Okay, so seaborn and matplotlib, these are the plots libraries which I'll be using in this live session. Okay, to demonstrate or to visualize the data which will derive. Okay, uh, then one more thing, what I'll do, I'll just use the display, okay, max columns option. Why? Because uh, normally I have already told you there is in total approx 61 columns, including the target variable. Okay, it means it is a quite few, a big data set, but the rows are very less. They are around 125, I guess. Okay, around 125. We'll see the size. Okay, around 125 only, but columns are 61. Okay, so features are 61, including the target variable. So not including target. Features are 60, and one is the target variable. So yeah, so that's why I'll this option as max columns, because whenever I do head, so I want that all the values, okay, should be shown to me. So because of that, because I want to see all the column. Okay. I just forgot the semicolon. Ah, not semicolon, what you say, underscore. Let me just load the data set, okay, quickly. So it is in CSV format, so I'll use read CSV. Okay, let me just copy the path. Okay, so I have put it in my downloads. So I'll just directly import it from there. So I'll directly read from that only. And let me just quickly have a look out at my data set, how it is structured, okay, how it looks like. So, okay, so this is how, okay. So now let's just understand all the columns. So I guess the column names, by looking at them, I can say that they are already in a standardized format, because as you can see, the names, they are in lower cases, and the gaps between, I mean, suppose if the name is of two words, so it has already been combined with the underscore. It means it is already in a standardized form. I can clearly see that, okay. Yeah, all of them is in a standardized form. So I don't need to do anything with my column name, okay. That is totally fine. GPA being my target variable, okay. So based on all the values, the GPA is calculated, okay. And as I can see, gender is in 1 2 format. And one more thing, gender here, one means the male and two means the female, okay. So yeah, that is also one thing. So don't get confused. Okay, so breakfast, one. Calories by chicken is 4, means as you can see, it's in numeric format. I don't know whether it is in numeric or not, okay, because it can be in string also. For that, I need to check with it uh, information. So with the info function, that will be clear. So we'll see that. But in calories day, how many calories per day? Then in calories gone. Then there is coffee. So if that particular, I guess, okay, let me just do what df dot tell. So if that particular, means suppose if it is in a breakfast, so it is already in numerical format. It means if that particular student is having breakfast, means one. If none, then zero. Okay. Uh, then again for coffee, it is 2 times per day, 1 time per day. Comfort food. What is the comfort food? So it being comfort food being the food the student like, I guess. Yeah. The reason for the comfort food. Okay. As I can see, stress, bored, anger. It is totally a survey based. Okay. Mm, so comfort food reason coded based on 1 to 10 scale, I guess. Then there is cook, the rating for the cook, I guess. Comfort food reasons coded. Okay. Then cuisine, which cuisine? Okay. Diet current, diet current coded. Okay. Drinks, eating changes, eating changes coded one. Whether they eat out, what is the employment scale, ethnic food, whether do exercise, father education, father profession, favorite cuisine, okay, favorite cuisine coded, favorite food in the childhood, fries, fruits, how many fruits a day, grade level, Greek food, healthy feeling, healthy meal, ideal diet, okay, income, Indian food, Italian food, life rewarding, marital status, meals, dinner, diner, friend, mother education, mother profession, nutritional check, on off campus, parents cook, pay meal out, portion food, self perception, weight, soup, sports, Thai food. Okay, and there are many more. As you can see, veggie stays. I'll share you the data set so you guys can have a quick look around it. Okay, waffle calories, how many, and what is the weight? I guess in pounds. So this is how our data set looks like, and this is how the columns are there. Okay, now let's just understand the shape. Let's just determine the shape of our data set. What is the shape? So as you can see, 125, 61, it means total 125 rows are there and 64 columns. 61, sorry, 61 columns. Okay, let's see the whole detail about our data set. So as you can see, object, integer, and okay, so I can see out of 125 in GPA there are missing two values. In gender, it is okay. Okay, in calorie stays means there are missing values, and on okay, quite okay. So it is in approx means there are missing values present in most of the columns. I can say that. Okay, so okay, we'll understand that and we'll see how we can fix them later on. Okay, so now as I can see, there are values in which there are missing values. So let's now do what? uh, let's just first see the statistical summary. Okay, so we are getting it only for the integer values, as we know that how many float. So out of this 61 float values, float categories are 20, float variables, float columns. Integer has 27, and object means the string ones have 14. Okay, okay. So the mean calories by chicken is 577. Okay, minimum is 265, max is 720, and it is based on 125 students. Calories have some missing values, okay, and only values for 106 students are present. Based on that, the mean value is 3.02, minimum is the 2, max be the 4, okay, and so on. It will be including all the numerical columns, okay, all including the float and the integers, okay. Now let's just do what? Let's see the missing values, that how many missing values are present. So df dot is null. Okay, you guys can use is na2. Okay, that will also do the same thing. Okay, I'll be getting like this. So what I can do, I can use a loop 2. Okay, so on the type sports there is 26 values, okay, which is missing. On comfort food reason coded there is 19, 19, 17, 13, 9, 3, 3, okay, and so on, 1 1 values. Okay, So now let's determine the total percentage. Okay, so let's see that also. So based on the percentage, in the last session only I have discussed that if it is less than 5%, okay, so what we can do, we can directly drop the column. Okay, if it is more than 5%, then what we need to do, then we need to try to fill it. Okay, try to fill it with other values. Okay, I cannot do like this. So, okay, so I need to directly apply the loop. Okay, so 2020. So as I can see, um, now based on that, I can see that most of the columns, okay, have a quite few with 20-15% data is missing in them. So, uh, and in our total data set, I have, as we already know, that there are 60 columns, okay, and there are 27 integer and integer float values, and other than that, the list of the 14 columns are there, which is object. So I can use a simple approach based on the percentage which we have derived. I can just directly retrieve the number, the data types, which is in numerical form, okay, float and integer, and I can fill them with the median value. Okay, why median? Because median being the more accurate one, because of that, okay, I can directly fill them with the median. So that I can, okay, that I can do. And for the objects, what we can do, for the objects, we can just simply fill it with the mode, the most common one, the most common which has occurred most commonly. I can fill them with that. That also I can do it. Okay, so that will be the most easiest way which we can just follow it. Okay, to bring out more good insights. Okay, so let's do that. So first let's try to deal with the numerical column. So here what we'll do, we'll fill the numerical columns with the median. Okay, and the purpose behind it will be that the median will be the most robust for the outliers. Okay, so because of not going with the mean, I'll go with the median here. Okay, so uh, let's do that. So first of all, I'll store all the numeric values, all the numeric columns in num underscore calls. Okay, so df dot select d types. Okay, this function is used to select all the d types, all the data types based on whatever we are going to write here. So we will write np dot number. Okay, and I'll mention here columns. So based on this particular, okay, number, it will derive all our columns. Okay, and it will put it in our num calls. Then what we'll do, then on the num calls, means on all the columns which we have fetched, okay, we will perform and we'll fill it with the median. Okay, so again we need to access the num calls dot median. Okay, and let's just run the cell. Okay, I have made a spelling mistake, I guess somewhere. Name num. Okay, numbskull. That will work. Yeah. This is what we have done. So we have basically used the median to fill the numerical columns. First of all, we have extracted all the numerical columns. Then we have tried to fix it with the median value. Okay, and that successfully um, we have performed. Now for the categorical columns. So again, we'll do the same thing. Everything will be same. Just here we are including the numbers, all the numbers data type. Here instead of numbers, we'll use object. That's the thing that is going to be changed. Otherwise, everything will be same. Okay, so let's do that. So for all the categorical columns, okay, select df dot select d types include object dot columns. Now I'll use a loop to iterate over each column, okay, one by one, and then I'll just fetch, means for each particular column I'll fetch the mode and I'll fill that particular column with the mode value. Okay, that is the thing which I'm going to do. So for that I'm using the for loop. So for call in category calls, here I'll extract the each column. Okay, and I'll apply the fill in a function here. Again, I want to find the mode of that particular column. So that's why df again the call dot mode, and from mode I'll extract the first value, because mode gives us, it returns couple of values. Okay, it returns multiple values where at zero position there is the most common one, then at one position the second common, then at two there is the third common. Okay, so yeah, so I want to extract the most common and I'll make in place equals to true. Now most of the people say, why using in place? Okay, see, in place, if you'll just directly, if you'll not use in place, okay, and you'll directly write df call dot fill in it, so it will be, the changes will be done temporarily. Okay, and that will be not affected in your data set, in your data frame actually. So if you want to affect there, means if you want to make the changes, so that's why we have to make in place equals to true. Otherwise what you need to do, otherwise you need to apply this technique. If you're not using in place, then you have to use explicitly this thing. Okay, that you have to first of all extract the column, then you have to use the fill na, and then you have to do whatever you want to do. Okay, and then here what you need to do, in the same column you need to write like this. Okay, so the changes will be replicated. Otherwise if you want to replicate without using this technique, so you can use in place equals to true, that will make the changes permanently. uh, Now here what we are doing, as I've already said, we are replacing the missing categorical values with the most common frequency. So let's execute this cell. uh, a value is trying to be set. Yeah. So yeah, that has been executed with the warning. Okay, I have not filtered out the warnings, because of that I am just getting to see that. Okay, if I've applied the filter, I forgot to do that. So yeah, but it has been affected. Okay. Uh, there was one column, uh, which is, if I remember, yeah, um, as the weight. Guys, now I'll show you one more technique. Okay, using the as type, we are going to will change the type of. Okay, we'll change the type of this column to to a numeric data type. Okay, so what I'll do basically, As you can see, weight is the column which is in object format. Okay, so it means there are values which is put it which means which is in object format, but actually the weight should be in numerical format. Okay, so for that particular thing, now there could be multiple columns. Okay, there could be multiple columns which can be in object, but they should be in any numeric format. So you can try it with your own, but the one common one is that is weight. Okay, so I'll show you that how we have to do it. Now it's very easy. Okay, there is no rocket science. There is built-in functions, there are built-in techniques which we have to use. So first of all, extract the weight column. Okay, then what you need to do now to make the changes affected on your column. That's why first written df weight. Then again I'm extracting df weight. Okay, then I'll make sure that all the values is in str. Okay, then what I'll do from this str column, there could be values. No, let me show you. Okay, so as you can see, um, there are values 187, 155. Then there is means because it was a survey, okay, done by someone. So based on that, anyone can answer any value. There was no limitation on the values. Okay, if it will be a professional way of collecting the values, then there should be a validation technique. Whether if a person is not entering an integer value, then there should be means that is the thing with proper inspection and all. So that I'm not saying, but because it was a survey, so data is very inconsistent. As you can see, people have entered whatever they want. So some people have given the exact value, that is 187, 155, 190, but there are some few people who have entered I'm not answering this. Okay, so they must have get offended. That is a different thing. But yeah, not sure 240 means he has entered 240 but not sure also. So based on that, okay, now lbs units. So there are many rest of the values looks good. Okay, but there are some object value means string values also. So now what we'll do for this particular thing, first of all, we'll convert everything in again in str. Then we'll make sure that from this we are only extracting the integer values. Okay, so we are not going to extract I'm sure, I'm not sure. Okay, that kind of thing. Then we'll only extract from each row. We are going to from that particular column weight. We will only extract the string integer values, the numbers. Then that numbers after extracting, again we are going to convert it. Okay, using the function. Okay, and then what we'll do there, we will make sure that other than if there are any more value means other than the numeric value, if there are something is in a string. Okay, suppose I'm not sure like this, so that should be converted to nan. Okay, and then we'll fill the weight, okay, with the median. That will do. Okay, so let's try that. So first of all, I have make sure that it is in str. Then let's extract it. So why I have written backslash this is going to extract only the integer values. Plus means if there are multiple integer values, so it will extract that also. Okay, so that is there. It is actually a regex kind of thing. Okay, then we'll use a function called as tunumeric, which is present in pandas. So it is one of the pandas function which is used to convert, okay, a particular column to a numeric. Okay, Now here, one more thing which I'm going to do here, that is I'm using a parameter errors, okay, in which I'll write here uh, course course. That means that that will do that particular thing, that if I'm not going to use that, so if there will be any value which is an string value, okay, so then it will be converted, but it will give you an error, okay. So that we don't want. So what we want, we basically want that if there are any string values other than numeric values, so that should be converted to a nan, okay. So that we want. So because of that I have used this. And now we have converted in this, with this particular code, all the numeric values, okay, that will be extracted, then it will be converted to a numeric format, and the values where we have string, so that will be converted to nan. And then what we need to do, then we'll fill that with the median, okay. So that is the approach which will follow for the weight, okay. Now there are I have already shown you that there are multiple what you say, there are multiple values, multiple columns, okay, there could be more, okay, which has some missing value, or which is in, suppose, which is in object format and needs to be converted in numeric. So you can go ahead and check it out. It based on the understanding, okay. I am also just seeing the data set now only, okay. So because of that, what I am understanding, okay, because first of all I have to understand, and then I have to make you guys understand. So yeah, let's run this cell. So again, that is done. Let's try to find out some duplicate values using the, okay, so 0. So because there are 0 duplicate values, so we don't need to do anything. So now I guess I have, we guys have done quite a few things, okay. So the data cleaning part, I guess almost what we have, okay, let's just give a, re-verify it if there are some columns which is missing. So we'll again, so as you can see, uh, so you can see there are no more missing values, okay, means we have filled every one of them. So now let's just do what, uh, let's just perform the univariate analysis, okay, which is one of the analysis present in EDA, exploratory data analysis. So let's first start with the distribution of the GPA, okay, the grade point average. Let's figure out that. So we first start with the, so what we need to do, we'll first start the figure. So we will not mention any size, okay, so it will take the standard one. Let's use the hist plot. Let's show the title being the distribution of GPA. So this is the plot which we get. Okay, this is the distribution plot for for the GPA, the grade point average. Okay, based on it gives us the frequency for each range. Okay, okay. Let me just do what, it is not visible. So plt dot xticks. I have to mention rotation equals to 45. Then it should, I guess, work. Yeah, then it is readable. I just wanted to make it, or let me just make it 90 only. That will, I guess, make it more readable. Yeah. So now as you can see, so as you can see, this all GPAs are spread across all students, okay? And this plot basically gives shows us the frequency of the students, okay, at different GPA, okay, the different GPA ranges, as you can see here, 2.4, 3.654, and based on that, uh, it gives us the frequency. Okay, now let's understand the gender, okay, the gender distribution. So I've already told you one will means the gender is here now mapped into one and two, one being the male, okay, and two being the female students, okay. So gender distribution. So this is the value count 176 and 249, okay. Yeah. So this is the gender distribution, okay, bar plot, which gives us a, now as you already know the number, but to visualize it, to make it more interactive, uh, you can see this that the males are 76 and for the females it is 49. That is the total count, so male being the more, okay. So here as we can means from out of 125 values we can see that the data set is more, if we'll consider it based on gender, so we can say that it is more biased towards the male, okay, based on the gender, okay. So for males it might interpret or predict accurate values in comparison to females, okay, it might so happen. Now let's have the data set now based on the calories per day. So plt dot figure sns dot, here we'll use the scatter plot, okay, to see how the values are spread. So that's why we will use the scatter plot. Now why we are looking with the calories per day, because see, gender alone here is means not strongly affecting the GPA. So then what we can do, let's quickly review with the calorie per day, okay, and then we'll see the gender, okay. Or let me just do what first, make it with the gender, and then we'll go ahead with the calories per day. Okay, so then I need to use box float for the gender, where I'll mention, because there could be outliers too. So x-axis being the gender, y being the GPA, will determine our data frame. Plt dot show. Okay. Uh, so let me just give you a more, yeah. So this shows us the median, okay, median GPA and the spread for each gender, as you can see. And here you can see that both genders have similar median GPA, approx 3.2 to 3 to 3.5. There are slight variations that exist here, okay, but there is no that much dramatic difference, okay. Now let's analyze the same thing with the calories per day. So GPS versus, so this part, okay, you can see the plot, that is calories per day versus the GPA, okay. Now this particular plot shows the relationship between the total daily calories and the GPA, okay. So total daily calories, okay, as you can see, according to the GPA is, so you can see that points are scattered, but there is no clear slope here, okay. So there is no strong linear trend which we can see between the calorie, which is between the calorie intake and the GPA, okay. So from this we can say that daily calories alone here do not predict the GPA, okay. So the GPA is based on the all the other feature also, okay. And based on this we can uh, derive one more thing, that this particular thing in the GPA is not entirely dependent on the how much food quantity is means the students are taking, okay. There are other factors too that is going to affect it. Okay, now let's see the how the all the columns are correlated with each other. Okay, so let's perform that analysis. Okay, that is called as the correlation matrix analysis. So let's see that. Based on that, then we can, means I've showed you all the approaches that how you can use the all kinds of plots. So then it will be easy for you to understand that how these things are done. Okay, and then I'll just provide you the data set, and the rest of the insights you can bring out with your own. Okay, and then you guys can tell me in the next live session, or the comment section will be always open, so you guys can come and comment anytime when you want. So that is also one thing. Okay, so let's do that. So let's bring up with the correlation matrix. So first of all, for that we have to define the correlation. uh, so for that, core matrix, all the numerical columns dot core. Okay, now let's just plot it. Now here we are going to use the heat map. Why? Because there are approx 60, or if we'll exclude 13 columns, so then also there will be a quite few large number of columns. So that's why we are using this core matrix, in which we have, then we'll set the C map to cool warm. Okay, so with this color you can see the warm shows a positive linear relationship. Okay, so correlation actually ranges between 1 to -1. Okay, 1 represents the values which are close to 1, that represents your uh, the values which are highly positively linearly related. Means if I'll give you an example. Okay, so see, the means the column is the most highly positively uh, related with itself. So gender, with gender, as you can see, it is the red color, the hot. Okay, that means it is, means with itself it's the highest. So that is one way to check. And then rest of the things, as you can see here, some of the values are 0.6. Okay, it's very, I have to zoom it a little bit. Okay, then you can understand by looking at this ethnic food, I guess. Okay, ethnic foods with the sports. Okay, so those who eat the ethnic food. Okay, so with this you can say that in sports also they are active. Okay, so they participate in sports also. So this is the positive relationship which is okay shown here. So that is one of the examples. Okay, and then based on that, now you, as you can see, it is very, means there are many columns, because of that it is not quite few that much, but yeah, this shows us that particular thing. Okay, and minus be in the negative. Okay, negative means that with the increase of suppose with the increase of some, if you're not eating fruit day. Okay, so there could be something in which you are getting deficient. Okay, in some, means your overall performance, or with that particular, suppose, let me just give you an example. Okay, let's this one. Self perception weight, ideal diet coded. Okay, so basically, the values which are related means close to -1. That means that with the increase of some, means with the increase of that particular thing, there will be a decrease in the next, the correlated column. Okay, so that is what. Okay, so if you want to make any insights from, bring out some insights from this, so you can easily do that. Now, overall, what we have done till now, so this shows that. Uh, So what we have done, we have seen the GPA here shows the moderate variance, okay, across the calorie intake levels, okay. And as we have seen, one of the columns, okay, which were very hot, okay, so they gives us that there are several calorie related variables which are strongly correlated. So based on that, the GPA is calculated. And then there was some columns were that just needed significant cleaning, okay, because approx 20% of the data values were missing in that. Okay, so the values, one more thing which I wanted to tell you, if the values are more than 50% missing, okay, so then also you can just remove that particular whole column, because then it doesn't matter. Okay, if the more than 50% the values are missing, so that will be totally a impure thing, and that is going to affect, if you are going to fill those values also, so that will be also not that much accurate, so it can cause uh, anonymity in your predictions. So it's better to just remove them. Okay, at the end we have just cleaned the data set. Okay, we have structured it, and then we have just bring some insightfuls from our data set. Okay, and we have performed EDA. So that that's it for this live session, guys. Okay, in the next one we'll come up with one more data set, and if you guys want me, you can just tell me that what kind of data set I should use, because in the last um, live session someone has told me to more work on the data cleaning. Okay, bring up data sets which have data cleaning, so that's why I'm coming with the data cleaning things. Okay, the data sets which require data cleaning. Now, if anyone have problem in any one of the things, means data cleaning, EDA, or some ML featuring, so you guys can just let me know in the chat, so that I can, next time I can bring up with that kind of data set. Okay, so that's the thing. And for the data set and my class file, I'll just give you a link. You can go and just download it from there. So that's all for this live session. Thank you so much, everyone, for joining the live session, being there till the end, watching the live session, getting to learn something new. Okay, try to be good in Python, try to learn data analysis. We have our whole data analysis playlist going on. And if you are uh, a basics, you don't know about Python, you want to learn Python, then in you can explore our channel. We have many playlists created. Okay, so you can go and learn basics also from Python. I have also covered the basics. You guys can go and watch those videos also, those live sessions also. So I'm sure you guys will learn. Okay, so and you guys will like it. So please go and have a look on those videos also. If you don't know about basic, and those who are friendly with means the basics are clear, so then you guys can understand this. Okay, this is not that much hard. First of all, understand it, and then again we'll meet in the next live session. Okay, So, okay then, that's it. That's the time.